Children, let us continue the chapter quadrilateral. Now, the exercise 1 of the chapter is continued. Now, the fifth question. Show that if the diagonals of a quadrilateral are equal and bisect each other at right angles, then it is a square. Here given that ABCD is a quadrilateral in which the diagonals are equal and bisect each other. We have to show that it is a square. You know that when the quadrilateral is said to be square, becomes square, if all the sides are equal and all the angles are equals to right angle. It must show the properties of rectangle as well as the properties of rhombus, that is all sides are equal and all angles are equals to 90 degree. If you prove that, then it becomes a square. Now you consider a quadrilateral ABCD. You take the solution given that ABCD is a quadrilateral in which diagonals are equal, in which diagonals are equal, that is which are the diagonals here, AC and BD. AC equals BD, and second, diagonals bisect each other at right angles. Diagonals bisect each other at right angles. That is, diagonals bisect each other means AO equals OC and OD equals OB, and at point O all four angles are right angles. That is given here. Angle AOB equals angle BOC equals angle DOC equals angle AOD equals how much? 90 degree. This much is given. Diagonals are equal. It means AC equals BD is given. Diagonals bisect each other at right angles means AO equals OC and OD equals OB. Bisect at O, and at O all the four angles are right angles. That is, angle AOB is equals to angle BOC is equals to angle DOC is equals to angle AOD. All are right angles. So we have to prove that the four sides are equal. We have to prove that AB equals BC equals CD equals DA, and angle A equals angle B equals angle C equals angle D equals 90 degree. We know that the diagonals of a parallelogram bisect each other, and also its converse says that if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Therefore, you can conclude that ABCD is a parallelogram. The quadrilateral ABCD is a parallelogram as its diagonals bisect each other. Therefore, you write, we know that if the diagonals of a quadrilateral bisect each other, if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Then it is a parallelogram. So you can say that quadrilateral ABCD is a parallelogram. Therefore, quadrilateral ABCD is a Quadrilateral ABCD is a parallelogram. Quadrilateral ABCD is a parallelogram. Now in parallelogram, opposite sides are equal, opposite angles are also equal, and the sum of the consecutive angles on the same side of the transversal are supplementary, and in this parallelogram ABCD are also consecutive angles are supplementary. Therefore you can write here, therefore you write AB equals DC and AD equals BC. Reason, you know, opposite sides of parallelogram are equal. Opposite sides of parallelogram are equal. But here we have to prove that all the four sides are equal. That is AB, BC, CD, DA are equal. If you proved AD equals DC or DC equals CB or BC equals AB, then naturally you will get that AB equals BC equals CD equals DA. Now let us prove the adjacent sides are equal. So let us take in triangle AOD and triangle DOC. In triangle AOD and in triangle DOC, here it is given that AO equals OC because diagonals bisect each other. So you write AO equals OC given, and OD equals OD is also given. OD equals OD, that is common side, and you can write angle AOD equals angle DOC. Angle AOD equals angle COD or DOC. Both are equals to 90 degree because diagonals bisect at right angles. At a point O, all the four angles are right angles. Therefore, that is also given. So you write, therefore, triangle AOD is congruent to triangle DOC. So you can say that here which congruence rule is used, that is side angle side. So write SAS congruence rule. SAS congruence rule. According to SAS congruence rule, these two triangles are congruent. Then you can write AD equals DC. AD equals DC. So here consider this is the first what is given, and second you proved. The reason you can give here according to CPCT. According to CPCT, AD equals DC, as AB equals DC and DC equals DA and DA is equals to BC. So you write from first and second, you can write that from first and second, you can write, you start from DC. Here you take what? AB equals DC equals DA equals BC. AB equals DC equals DA equals BC you got. That is in order you can take, that is AB equals BC equals CD equals DA. You got all the sides are equal, and here you need all the angles are right angles. If you proved any one angle is right angle or any two angles are right angle, then you can say that all the angles are right angles and it is a square. Now you take the two angles which are on the same base. So let us take on the base DC, angle ADC is there and angle BDC is there. You take the two triangles. In triangle in triangle ADC and triangle BCD. In triangle ADC, in triangle ADC and triangle BCD. And triangle BCD. Write the equal parts here. You know that in triangle ADC and BCD, DC equals DC, common side you can write. DC equals DC, that is a common side, common. And AD equals BC, you proved. AD equals BC, proved. AD equals BC, that proved here. Next, also you can say here the diagonals are equal, therefore you can say that AC equals DB, that is given. Diagonals are equal. AC, diagonal AC equals diagonal BD, that is given. So therefore you can write that triangle ADC is congruent to triangle BCD according to which congruence rule? Sss congruence rule. Sss congruence rule. Now once you got that they are congruent means corresponding parts are equal. So you can write angle ADC equals angle BCD. So you write angle ADC equals angle BCD. But you know that in angle ADC, if you take the angle ADC and BCD, here they are the angles here on the ends of D and C, means they are the consecutive angles. If you take the parallelogram, they are the consecutive angles. Or here also you know that angle ADC and angle BCD are the interior angles on the same side of the transversal DC of line, parallel lines, AD parallel to BC, that also you can take. Or otherwise here they are the consecutive angles of the parallelogram. Consecutive angles of the parallelogram are supplementary. So there's some you take and we know that, or you write, but angle ADC plus angle BCD equals how much? 180 degree. 180 degree because consecutive angles of parallelogram are supplementary. So you take, therefore angle ADC equals angle BCD, both are equals to 180 by 2, that equals 90 degree. So you got the angles are 90 degree and the sides are equal, as you take as AB equals BC equals CD equals DA and angle D equals angle C, both are equals to 90 degree. You can say that ABCD is a square. ABCD is a square. All angles are equal to 90 degree and all sides are equal. All angles are equals to 90 degree and all sides are equal, you got. Therefore, here ABCD is a square. Now let us take the sixth question. Question number 6. What is that question? Diagonal AC of a parallelogram ABCD bisects angle A. Show that it bisects angle C also. Second one, ABCD is a rhombus. It is given that ABCD is a parallelogram. We know that in parallelogram opposite sides are equal, parallel, and opposite angles are equal. And here AC is a diagonal. It bisects angle A. We have to prove that it also bisects angle C. Now you know that here the AC becomes the transversal of the parallel lines AB and CD, and also it is the transversal of the parallel lines AD and BC. You know that the alternate angles made by the transversal of parallel lines are equal. So you can take that here angle ACD is equals to angle BCD, and angle BAC must be equals to angle ACD, and also opposite angles are equal. Now you write here, given that solution, first one you take solution, given that ABCD is a parallelogram, ABCD is a parallelogram, and diagonal AC bisects angle A. Diagonal AC bisects angle A. Bisects angle A. So you can write, therefore angle DAC equals angle angle BAC. Angle DAC equals angle BAC. Both are equals to half of angle DAB. Both are equals to half of angle DAB. Let us write they are equals to A. They are equals to A. So you take this is A, this is A. So you take, that is, let angle DAC equals angle BAC equals A. And also here you know that angle ACD is equals to what? Angle CAB. Angle ACD equals angle CAB, you write, and angle ACD equals angle BAC. Therefore angle ACD is equals to what? A. That also becomes equals to A. Consider this is the first. Here what is the reason you are going to give? Why angle ACD is equals to angle BAC? Angle ACD is equals to angle BAC because they are the alternate angles. They are the pair of alternate angles, right? Pair of alternate angles. Therefore they are equal. Therefore as angle BAC is equals to A, we have taken angle ACD is also becomes equals to A. Angle ACD equals A. Now next you write angle, here the angle, you have taken the angle ACD. Now let us take the angle ACB. Angle ACB is equals to angle DAC. They are also alternate angle. Angle ACB equals angle CAD. Angle CAD or angle DAC. Angle DAC. Therefore angle ACB is also equals to A. So you consider this is the first. Here we have taken angle DAC and angle BAC are equals. Let them they are equals to A. Now you know that angle ACD equals angle BAC. Angle ACD equals angle BAC. Therefore you can write angle ACD equals A. That is from, consider this is second, reason is here from first. In first you have taken that is A. Therefore, angle ACD equals A. Again you take the other angle ACB. Angle ACB. This angle ACB is equals to again angle CAD. ACB is equals to angle CAD or DAC. So you write angle ACB is equals to angle DAC. Why they are equal? Why they are equal? Because they are also pair of alternate angles. Pair of alternate angles. Here also you give the reason pair of alternate angles. Here also there are also pair of alternate angles. Here angle ACD is equals to angle CAB, pair of alternate angles, and angle DAC is also is equals to angle ACB. Angle ACB and angle DAC are equals because that is a pair of alternate angles. Therefore, as angle DAC is equals to A, from first you can write, therefore, angle ACB is equals to A. Consider that is the third. That is the reason is same from first. In first we have taken both are equals to A. Therefore, you can say here both these are equals to A. Therefore, you can say that therefore angle ACD equals angle ACB. Angle ACD equals angle ACB, and these two are the angles made by the line AC, that is divided by AC. So you take that angle ACD here, angle DCB. Angle DCB is the sum of angle ACD and ACB. So you take any one angle here. As both are equals, you take both are ACD or ACB ACB. So let us take ACD plus angle ACD. Here it is given. Here given that they are equal. That is DAC and BAC are half of DAB, that is given here. So here we proved ACD and ACB are equal. Consider this is the fourth, and the reason also we give from fourth. Therefore here you can say angle DCB equals to angle ACD. So half of angle DCB equals what? Angle ACD. Angle ACD. So here angle DCB is bisected by AC. So therefore AC bisects angle C. AC bisects angle C. Next we have to prove that ABCD is a rhombus. You know that in a rhombus all the four sides are equal. It is given that ABCD is a parallelogram. In parallelogram opposite sides are equal. But here we have to prove that adjacent sides are also equal. To prove AB equals BC, if you proved AB equals BC, then all the four sides becomes equal. To prove that AB equals BC, here you got that angle DAB equals angle DCB. They are the opposite angles of the parallelogram, and here both are bisected, means halves of equals are equals. Therefore all the four angles made here are equal. Therefore you can say that these two angles are also equal, these two angles are also equal, and as the sides opposite to the equal angles are equal, then you can say that AB is equals to BC. As AB is equals to BC, you will get all the four sides equal. So right, we know that halves of equals are equals. Equals are equals. Therefore, half of equal angles. You know that in parallelogram, therefore, as angle DAB equals angle angle DAB equals angle DCB. Half of angle DAB equals half of angle DCB. Then half means you can take here angle DAB and angle DCB are bisected by AC. Therefore, you can write half of angle DAB equals half of angle DCB. Therefore, all the four angles. Therefore, you write, therefore, here half of angle DAB equals half of angle DCB. Therefore, all the four angles, angle DAB equals angle DCB equals angle ACB equals angle CAB equals angle CAB. And in triangle ABC we will get AB equals BC, and in triangle ADC we will get AD equals DC. The reason, angles opposite to sides opposite to equal angles are equal. Sides opposite to equal angles are equal. Equal angles are equal. Therefore, all the four sides are equal. You consider here opposite sides are equal, adjacent sides are equal. Therefore, AB equals BC equals CD equals DA. AB equals BC equals CD equals DA. Therefore, here you can say that ABCD is a rhombus. Therefore, ABCD is a rhombus. ABCD is a rhombus. Question number 7. ABCD is a rhombus. Show that diagonal AC bisects angle A as well as angle C, and diagonal BD bisects angle B as well as angle D. Now here you know that as ABCD is a rhombus, all the four sides are equal and diagonals bisect at right angles. Now you write that one. So let us have the solution. ABCD is a rhombus. ABCD is a rhombus in which AB equals BC equals CD equals DA, and diagonals bisect at right angles. Diagonals bisect at right angles. You write DO equals OB and AO equals OC, and also the four angles made at a point O are right angles. That is, angle AOB equals angle BOC equals angle DOC equals angle AOD equals 90 degree. This is according to the property of the rhombus. Now we have to show that angle A and angle C are bisected by the diagonal AC, and angle D and angle B are bisected by the diagonal DB. Now if you take these two triangles and prove that they are congruent, naturally these two angles becomes equal and that angle A is bisected. Similarly, if you take these two triangles, then also if you prove them as congruent triangles, and these two angles becomes equals and they are bisected. So let us prove that. First one you take in triangle AOD, in triangle in triangle AOD and triangle AOB, in triangle AOD and triangle AOD, write AO equals AO common side, AO equal AO common side, and DO equals BO given, DO equals BO given because diagonal bisect each other, and also the angle at O are right angles, so you can write angle AOD, and also you can take that all the sides are equal. Also you can take AD equals AB also you can take, or angles also you can take. So you write AD equals AB, that is also given. Then you take here, therefore triangle AOD is congruent to triangle AOB, therefore you can write that angle DAO equals angle BAO. Here according to which congruence rule they are congruent? According to SSS congruence rule. SSS congruence rule. So angle DAO equals angle BO, they are the corresponding angles of congruent triangle. You write CPCT. So you got that, therefore angle A is bisected by AC, or you write, so therefore AC bisects angle A. Therefore AC bisects angle A. And also similarly you can prove that triangle DOC is congruent to triangle BOC. Similarly triangle DOC is congruent to triangle BOC. So you write, and triangle DOC is congruent to triangle BOC. That is also according to SSS congruence rule. SSS congruence rule, because if you take that to triangle, there also CO common, DO equals OB given, and BC equals CD also given. Naturally, according to SSS congruence rule, triangle DOC is congruent to triangle BOC. Therefore, you can say that the two angles, therefore angle DCO equals angle BCO. CPCT you will take, CPCT. So AC bisects angle C. Therefore you can conclude that diagonal AC bisects angle A as well as angle C. Similarly, here if you want to prove the angle B and angle D are bisected by the diagonal BD, here you can take, and also triangle AOB is congruent to triangle BOC, that is by the SSS congruence rule, and also triangle AOB is congruent to triangle BOC according to SSS congruence rule. According to SSS congruence rule, therefore you write angle ABO equals angle CBO, that is CPCT. Therefore DB bisects angle B. And also you write, and also triangle AOD is congruent to triangle COD according to SSS congruence rule. SSS congruence rule. According to SSS congruence rule, Therefore, you can write that angle ADO equals angle CDO. Angle ADO equals angle CDO. Therefore, you can say that, therefore, DB, diagonal DB bisects angle D. Therefore, you can say that diagonal DB bisects angle B as well as angle D. Diagonal DB bisects angle B as well as angle D. Now come to the question number 8. ABCD is a rectangle in which diagonal AC bisects angle A as well as angle C. Show that first one, ABCD is a square. Second one, diagonal BD bisects angle B as well as angle D. Now it is given that ABCD is a rectangle. You know the properties of rectangle. In rectangle, diagonals are equal and all angles are right angles. So you write solution here. Given that ABCD is a rectangle, ABCD is a rectangle in which all angles are right angles. All angles are right angles and diagonals are equal. And as it is a parallelogram, it is also having all the properties of parallelogram. Opposite sides are equal, opposite angles are equals, diagonal bisect each other. Now here we have to show that first one, ABCD is a square, and also it is given AC bisects angle A as well as angle C. Right? AC bisects angle A as well as angle C. And we have to prove that first one, ABCD is a square, means only we have to prove that all the four sides are equal. If you proved the adjacent sides are equal, then naturally all the four sides becomes equals because opposite sides are equal as it is a parallelogram. As AC bisects angle A and angle C, angle A and angle C are right angles. Bisects means the four angles formed by the diagonal AC are of 45 degree. Therefore, you can write angle DAC equals angle BAC equals angle ACD equals angle ACB. All are equals to half of 90, that is 90 by 2 equals 45 degree. All are equals to 45 degree. Therefore, here the triangle ADC and triangle ABC are isosceles triangle. So, the angles opposite to equal sides are equal. Therefore, you write, therefore, in triangle ABC, as angle DAC equals angle ACD, angle ACD, here DAC equals angle ACD, both are equals to ACD, both are equals to 45 degree, and therefore you can say that AD equals DC. AD equals DC. You know, sides opposite to equal angles. Sides opposite to equal angles. Equal angles. Sides opposite to equal angle. Here you take first one. Therefore, you can write that. Right? AB equals DC equals AD equals BC. So, you know, opposite sides are equal. Opposite sides of parallelogram are equal, or rectangle are equal. Rectangle are equal, and from first, and also from first. Here, why these four sides are equal? From first, and also opposite sides of rectangle are equal. Opposite sides of parallelogram are equal. So you got all the four sides are equal, and it is already given that angles are right angles. Therefore, you can write, therefore, ABCD is a square. ABCD is a square. In second part, we have to show that the diagonal bisects angle B as well as angle D. Here, what you have to show? Diagonal BD bisects angle B as well as angle D. Now, here you take the triangle AOD and triangle COD and prove that they are congruent. Here also you take triangle AOB and triangle BOC and prove that they are congruent. According to CPCT, you can get the result that these two angles are equal. Here also these two angles are equal. They are equal means they are bisected. Which is bisector? Angle B and angle D are bisected. So you write in triangle, for second one you take, in triangle AOD and triangle COD. You write first one DO equals DO common. DO equals DO common, and AO equals OC. AO equals AC. Reason that is given because diagonal bisect each other. And also you can take AD equals DC, that is proved. That is proved. So you can write that, therefore triangle AOD is congruent to triangle COD. According to which postulate? According to which congruence rule? Sss Congruence Rule. Sss Congruence Rule. Therefore, here you can write that, therefore angle ADO equals angle CDO according to CPCT. According to CPCT. According to CPCT, you got that angle ADO is equals to angle CDO. Now here, as these two angles are equal, they are the angles formed by the bisection of the angle ADC. Therefore, you can say that angle D is bisected by DB. Angle D is bisected by DB. Again, according to SSS congruence rule, triangle AOB is also congruent to triangle COB, and also triangle AOB is congruent to triangle COB. So, according to SSS congruence rule. Therefore, you can write angle ABO equals angle CBO. That is according to CPCT. According to CPCT. Therefore, here angle B is also bisected. Angle B is bisected by DB. Therefore, you can say that diagonal DB bisects angle B as well as angle D. Angle B as well as angle D. In this way, we got the proof.